Hello my dear students, welcome to my physics class. Our today's topic are electromagnet, effect of magnet on a current carrying wire, DC motor. This is a solenoid. We know when current passes through a wire, then a magnetic field is produced around the wire. And if current passes through the solenoid, then the solenoid acts as a bar magnet. When a piece of iron is inserted inside the solenoid, then a strong magnetic field is produced. The three metals iron, cobalt and nickel have special magnetic properties. These metallic pieces can be considered as an accumulation of individual tiny magnets, which generally don't act as a magnet as they are aligned in different directions. There are infinite number of tiny magnets inside these metals, but here the tiny magnets are oriented in different directions. They are not aligned in a certain direction, they are aligned in different directions. Therefore, the pitch of iron, nickel or cobalt does not act as a magnet. Here the tiny magnets are oriented in different direction, therefore the net magnetic field is zero. Therefore, this pitch of iron or cobalt or nickel does not act as a magnet. But here, when this piece is kept inside a solenoid or a coil, and if current is passed through the solenoid, then the magnetic field produced by that current aligns the individual tiny magnets. Here the current is flowing through this solenoid, that is, this current through the solenoid will produce a magnetic field, and due to this magnetic field, the tiny magnets, that is inside the iron, cobalt or nickel, these tiny magnets are aligned with the direction of the field produced by the electric current I. Here, due to this electric current, these tiny magnets are aligned, therefore the strength of the electromagnet is increased. Here this magnetic field is the combination of magnetic field produced by this current through this solenoid and magnetic field produced by these tiny magnets, which are aligned now in a certain direction. Therefore the strength of this magnet is increased. Here current is flowing through this solenoid and the iron piece is inserted inside this solenoid, therefore, and now it is acted as a bar magnet. When the flow of current through this coil or solenoid is stopped, then the magnetic field produced by this current will be disappear, and therefore the tiny magnets will be oriented again in a random direction. And when current passes through this wire or solenoid, then again the tiny magnets aligned in a certain direction and it acts as a bar magnet. But when there is no current flow, there is no magnetic field. Magnet produced by this method is known as electromagnet. Electromagnet produced by inserting a piece of iron inside a solenoid. Uses of electromagnet. Speaker. Here in case of speaker, there is a permanent magnet and there is electromagnet. Here solenoid or coil, and this is diaphragm. This is the construction of a speaker, that is, in a speaker there is a permanent magnet, electromagnet and diaphragm. When current passes through this solenoid, then a magnetic field is produced, and due to this magnetic field and due to this permanent magnet, the diaphragm of the speaker will be vibrated. And here this is diaphragm and this is the electromagnet. It is end of the copper coil, here permanent magnet and iron attached with the diaphragm. The current is passed through the coil according to the vibration of the sound wave, and due to this electric current a magnetic field is produced, and due to this magnetic field and due to this permanent magnetic field, the diaphragm of the speaker will be vibrated according to the vibration of the sound wave, and we can hear the sound from this speaker. This is the use of electromagnet in the speaker. Effect of magnet on a current carrying wire. Here a wire is shown inside the permanent magnet. This is the north pole and this is the south pole, and this is the electric wire, and current is passing through this wire in this direction, and magnetic lines of force is from north pole to south pole. This is the direction of the magnetic field due to this permanent magnet, and if current passes through this wire, a magnetic field will be produced around this wire. And here magnetic lines of force for the permanent magnet, north pole and south pole of the magnet, and these are the magnetic lines of force, and this is the magnetic field produced by the current passing through the wire. And due to this magnetic field, the upper part of the magnetic field produced by this permanent magnet will be cancelled by this magnetic field, because here the direction of the magnetic lines of force is in this direction and here the opposite direction. Therefore the upper portion, the magnetic lines of force will be cancelled by this magnetic field, but here the lower portion, the magnetic field is in this direction and magnetic field produced by this permanent magnet is also in this direction. Therefore in the lower portion the magnetic field is in the same direction. Therefore in the lower portion the combined magnetic field will be more, but in the upper portion it will cancel the magnetic field. Therefore in the upper portion less magnetic field, but in lower portion there are more magnetic field. Therefore the wire will be pushed in the upward direction. That is, when current passes through the wire will experience a force inside the magnetic field, and when current passes through the wire in the reverse direction, now in this direction, then here in the lower portion the magnetic field produced by the wire is the opposite to the magnetic field produced by the permanent magnet. Therefore in the lower portion magnetic lines of force or magnetic field will be cancelled by this magnetic field, but in the upper portion the direction of the magnetic field produced by the wire is the same as the direction of the magnetic field produced by this permanent magnet. Therefore in the upper portion the more will be magnetic field, but here lower portion the less will be magnetic field. Here weak magnetic field and here strong magnetic field. Therefore the wire will be pushed in downward direction. That is, here the direction is in this direction, the wire will experience this force, and here the wire will experience force in upward direction. Therefore, we can say a current carrying wire placed in a magnetic field experience a force. DC motor. Here, this is a permanent magnet, north pole of the magnet and south pole of the magnet, and it is a coil, and it's a rectangular coil. Here the current is passing through this wire in this direction and then in this direction. But we know when current passes through this wire will experience a force. This is north pole and this is south pole. When current passes through this direction, then it will experience a force in this direction. But here the current is passing in the opposite direction, therefore it will experience a force in this direction. Due to this opposite force, a rotation will be created in this rectangular coil. Therefore, the coil will be rotated due to these two forces. And this is the main principle of motor. Here, current is flowing through this coil and a magnetic field is produced around this coil, and due to this magnetic field and the magnetic field for this permanent magnet, a force is produced, and due to these forces the coil is rotating now. When the position of this coil will be changed, then the magnetic field produced by this coil will be changed. That is, the direction of the magnetic field produced by this coil will be changed. Now the north pole will be south pole and south pole will be north pole. Therefore, the direction of the force experienced by the coil will be reversed. But if we want to continuous rotation of this coil, then when the coil will change its position, then the current flow through this coil will be if we want the continuous rotation of this coil, then we have to change the direction of current flow when it will change its position. Therefore, a special mechanical technique is used here, and this technique is known as commutator. Here, by using this commutator, when this wire is in the right side, there is a green wire in right side, then current is flowing in this direction, but when it is in left side, then current is flowing in this direction. That is, here by using a commutator we can change the direction of the current flow through the same wire. Here through this green wire the current is flowing in this direction at a time, and again in this direction another time. Therefore, we can sense the direction of the current flow when the coil changes its direction using the commutator. Here this is the commutator, and here the commutator is connected at the positive terminal of the electric source, and another time it is connected to the negative terminal of the electric source. The same terminal is connected at the positive terminal of the cell and again connected to the negative terminal of the electric cell. Therefore, the coil can rotate continuously. In a practical motor, there are many coils around the armature, and each coil gets current from the commutator and the armature continues its rotation. This is the practical motor. Here many coils are used here. Homework: why a piece of iron is inserted inside the electromagnet?